All right, hey students, here are the percent yield practice problem answers. I think most of you are doing really well on these, but if you want to check or listen to how to do them again, here you go. So we have this equation, hydrogen plus fluorine gives us hydrofluoric acid. So if 2.545 grams of hydrofluoric acid were collected after the reaction and the theoretical yield was 3.01 grams, what's the percent yield? So the first thing I want to do is write down the actual equation for percent yield. That's actual divided by theoretical times 100. For this one, it's a straight up algebra problem. You don't need any stoichiometry. You just plug and chug your numbers. Uh, so remember, actual is what you get in real life, reality. So in this case, we got in like an experiment, we got 2.45 grams of hydrofluoric acid. So 2.545. Theoretical yield is what you would get like in theory, on paper, in using stoichiometry, and it's already been given to you. So we got 2.45 divided by 3.01, actual over theoretical, and then we'll multiply that by 100. Remember, for sig figs in chemistry, regardless of like, we would think this would be a 3 sig fig answer, but when we do percentages in here, we always take it to the hundred spot. So it's 81.40% yield, and that's our final answer. So that's just straight up plug and chug algebra. The next problem is a little more complicated in that we have to use stoichiometry to get the theoretical yield and then plug that number into our percent yield problem. So if 3.10 grams of hydrogen gas were used, so that number would go there. And 58.9 grams of hydrofluoric acid were actually produced. So I can't use 58.9 in the stoichiometry table because that's the actual yield, what we got in real life, what we got in the laboratory setting. Then it says, what is the percent yield? So I gave you a hint. Remember, you must find the hydrofluoric acid theoretical yield from the stoichiometry table. So I'm going to put my stars there. And that's where I'll find the theoretical yield. So I want to take that down. 3.10 divided by 2.02 gives me 1.53. Divided by 1 gives me 1.53 again. Carry that over, and I get 1.53. Now I'm going up, times 2 is 3.06. Molar mass of hydrofluoric acid is 19 plus 1.01, so that's 20.01, so 3.06 times that. Sig fig wise will give me a theoretical yield of 61.2 grams of hydrofluoric acid. Now I can use my previous number from the problem, my actual yield 58.9, with this theoretical yield 61.2. So the equation again is actual over theoretical, so 58.9 divided by 61.2, 58.9, what we found in the lab, 61.2, what we found in theory on the stoichiometry table, and times 100 would give me a final answer of 96.24%, which would be good. You can keep your job with that number. The last problem is very much an algebra problem. So if the theoretical yield for this reaction was 12.1 grams and the percent yield was 94.30%, what was the actual yield for this reaction? So you're going to have to use algebra to solve this, which hopefully you're really good at algebra. There's my initial percent yield equation, and when I plug in what I have thus far, this is what I know. I'm solving for the actual. I don't know what that is, so that's my unknown. I know my theoretical is 12.1. I know it's times 100, and I know I got a final answer percent yield of 94.30. So algebra wise, step 1, I got to get rid of that 100. So I'm going to divide both sides by 100, which will now give me a new equation of actual over 12.1 equals 0.943. Then to get actual by itself, I'm going to multiply by 12.1. So that's really 12.1 times 0.943, and that will give me a final answer of 11.4 grams of HF. And so those are your percent yield answers.